All right, lesson 3.7 gives us 3 types of variation. So variation just means that we are going to talk about one variable and the other one at the same time and what happens between them. So if you are still working on your homework, you are probably going to miss what I'm going to be talking about. All right, there are 3 types of variation. The first type of variation is called direct variation. Direct variation means that the two things vary directly. The variables vary directly. The equation that we use for this is y equals k times x. K just means it's going to stand in for a constant. I know that constant starts with a C, but we use the letter K to represent it. There's a proportion that goes with each type of variation as well. So the proportion with direct variation is y1 over x1 equals y2 over x2. This just means the variables are directly related. When one goes up, the other goes up. When one goes down, the other goes down. Okay, they do the same thing. The second type of variation is called inverse variation. What do you think of when you think of the inverse of something? Good, the opposite. So this equation looks like this. Y equals k divided by x. So now they're going to be doing the opposite things. So if they're doing the opposite things, we're going to do y1 over x2 equals y2 over, what do you think? x1. So they're doing opposite things. The third type of variation that we'll talk about is called joint variation. Joint variation means that two of the variables are working together to join together. So this equation looks like y equals k times x times z, where x and z are being multiplied together. This equation is this proportion, y1 over x1 times z1, so they're being multiplied, equals y2 over x2 times z2. Now you will not have to memorize this chart. Some of you already have an index card in your note or like in your binder. So we're going to, during a test, I'll let you use this portion. Okay, I'll let you do this on a note card and you can use this on a test. Now, the question that students have is, how do I know when to use the equation and how do I know when to use the proportion? We use the proportion when they give you more than one x and y. If they only give you one x and y, we're going to use just the equation. But if they give you more than one x and or y, that's when we're going to use the proportion. Okay, looking at some examples, they want us to state whether this represents joint, direct, or inverse variation. Number 1, even though they're using different variables, look at where your constant is. Your constant is here, right? And you have a variable over here and a variable over here. Doesn't this look like direct variation? Yes. And our constant is 12. So I want you to tell me what kind of variation, and then I want you to tell me what the constant is. What does number 2 look like? What type does number 2 look like? Inverse. It looks like inverse, right? Where the constant is on top and you have a variable on the bottom. Emily Harris, what is our constant? 4. Excellent. Number 3, Tish, what does that look like? What type of variation does that look like? Joint. Does it matter that there are 3 variables that are being multiplied together? It doesn't. Okay? So this is joint variation. Emily Hagee, what is our constant? 2. Excellent. Now what about number 4? Do we have a type of variation where the constant is by itself? We don't, do we? So that means that we need to move one of our variables over. So if I were to move one of the variables over, it doesn't matter which one I move, but I'm going to have to divide. So let's divide by W. If I were to divide by W, now what type of variation does this look like? Inverse. Cynthia, what is my constant here? Perfect. Now on number 5, again, the constant's over there by itself. Do we have anything where a constant is by itself? No. This looks like it might be inverse, but before I say that it's inverse, let's move a variable over. Let's move b over. Does anybody remember how we move b over?
Multiply.
Good. Multiply by b. So I get a equals 1/3 b. What type of variation is this? Brianna says direct. It kind of looks like an inverse.
It looks like k times x.
It looks like k times x. Does it matter that your k is a constant?
No.
It is not inverse because the variable is not in the denominator. If the variable is in the denominator, then it would be inverse. So Brianna was correct. This is direct. Kyle, what's my constant here? Perfect. 1/3. All right, so let's look at example A. It says, or part A, I'm sorry. Number 6 says, if y varies directly as x, okay, so that's the hint. It tells me which type of variation is happening. And y is 35 when x is 7. Find y when x is 11. First of all, one of the things that I would make note of is this. It's telling me that you should be using direct variation. Whichever variable they give you first is going to be the leading variable. Now, should we use an equation or should we use a proportion here? Do we have more than one? We have one y, but how many x's? 2. So we should be using a proportion here. So we're going to use our direct variation proportion. Direct variation proportion. Now this is the best way to label these and do these problems so you know what goes where. Whatever y value they gave you first, that's your y1. Whatever x value they give you first, that's your x1. Then it said find y, so that's going to be my y2 that I'm trying to find. And x equals 11 is going to be my x2. So I just did it in the order that I labeled it in the order that they gave me. So now I just fill in my proportion with the correct number. So y1 is 35 over 7.
Why did we do proportions in freshman year? Or I did 8th grade.
What'd you say?
Why did we do proportions in 8th grade?
So that when we get here, you know how to do them. Okay, how do we solve a proportion? Anybody remember how to solve a proportion?
Cross multiply.
There you go, cross multiply. Okay, so I'm going to do 35 times 11, and I want you to write this out, please.
And not equals 7y.
Excellent. Equals 7y2. You can write this step out, and then you can write the answer. You don't have to show the work in between, but I want you to at least show the step of writing the equation.
I don't like writing that too. So I have to do something.
Okay, so 35 times 11. y2. That's why it's in the lower. It's not an exponent. What do you guys say? I'm sorry.
385.
385. So the second y value here is 385. Okay, that's it.
What happened to the 7?
We multiplied 7 times, or we divided. Oh wait, is 35 times 11 385?
Yeah.
Oh,
Yeah, and then you divide it by 7.
sorry. So this is 385 equals 7y2. Now we'll divide by 7. Thank you, Hortensia. So my y2 value is really 55. It's not 7y squared. It's 7 times the second y value. Because if you look back at your proportion over here, you had to multiply 7 times whatever that was. So we're just letting y2 represent the variable. Okay? Questions on number 6? Okay, number 7 says if y varies jointly as x and z. So there's the directions about what's happening. Y varies jointly as x and z. And they're giving me multiple y's and x's. Do you guys see that? So this is going to be the proportion. And I think writing the proportion out is going to be really helpful when you go to plug things in. Okay, so I'm going to label the problems. The y equals 18 is my y1, my x1, my z1, I just went right down the line and labeled them. The first x's and y's, the second x's and y's. Mm-hmm. So I'm going to put 18 over 2 times 3 equals y2 over 5 times 6. Now let me encourage you. Before you cross multiply, you need to resolve this. So that becomes a 6, and 5 times 6 is 30. So before you cross multiply, simplify your multiplication there. So that now when you cross multiply, you're going to do 18 times 30. And you do 6 times y2. It's going to make life a little bit easier for you, okay? Go ahead and solve it out. What's 18 times 30?
640.
540.
I get 540. Alright. I did my head.
And then 540 divided by 6 is 90. Any questions about number 7? No, I would not. Because you're leaving more room for error if you do that. Okay? So I would just leave it as this. All right. Number 8. The volume of V of gas varies inversely as its pressure. So one of the things that I would do first before I continue reading is I know that volume varies inversely as pressure. That's the direction. So volume 1 is going to divide by pressure 2, right? Because it's inverse. They gave me volume first, so that's the one that goes first. And then I have volume 2 over pressure 1. Because that's how inverse variation works. Then I'll go through my problem and label what they gave. So if volume is 80, so that's my first volume. when pressure is 2,000, so that's my first pressure. Find volume, so that's my second volume, when pressure is 320. Now you just have to be really careful when you plug things in. Okay, so see if you can plug it into the proportion carefully. So you should have 80 over 320 equals V2 over 2,000. Make sure you plug them into the right spot. So then you have 80 times 2,000 equals 320 times V2. Okay, with your calculator, what answer are you guys getting? 500? Is that what you said? 500? Okay, so because this is a story problem, though, we need to make sure that we know what we're talking about. Volume is measured in what? What's the unit of measurement? Cubic centimeters, right? So our 500 should be 500 centimeters cubed, which is the same thing as cubic centimeters. Okay. All right, we're going to finish these up tomorrow.